You know what the heck's going on? I don't know. I don't need. I'm just reviewing real quick what's on the quiz tomorrow, so we're all set. All right, because we're not doing an official review today. We're moving on. Make sure you know you can identify the population versus the sample tomorrow. Population versus sample. All right. If I give you a scenario, you'll be able to pick off the population and pick off the sample for me. Make sure you know the difference between a survey versus a controlled experiment versus an observational study. Again, I'll give you a scenario. What's happening? Is this a survey, a controlled experiment, or an observational study? Or I may give you a scenario and say, what's best? Any issues with those three you want to go over? What's what? All right. Mean, median, and mode. Make sure you can find them off a table. Remember, your calculator will give you mean and median. You got to do the mode on your own. That's all on you. Yesterday, can we go range? Can we find the range? Can we find the interquartile range? Real quickly, that's really the only formula you need tomorrow, which is what?
Q1 minus Q3 minus Q1.
If you do Q1 minus Q3, you might have a negative number. Calculator will give you Q3 and Q1. Let's see, what other values did we find yesterday? Big one. Standard deviation. There's this, which is what? Population standard deviation, yep. And then there's a second one called the SX, which is sample standard deviation, yep. If the problem doesn't say which one to use, we assume we use population. Perfect. Yes?
Is the IQR always positive?
Gotta be. Yep. Because the quartiles go from your smallest number to your biggest. Like we take the first 25%, second, third, okay? So it's gotta be, Q3's gotta be bigger. And then what we're doing today, which is normal distribution. That'll be on the quiz as well. Which really is just a new place on your calculator. That's what that's gonna be. Anything up here? Now, I did the answer key earlier this morning, and I'm just going to let you know, keep this in mind. Check your darn values when you put them in your list, please, because there's not many questions tomorrow that I can give partial credit on. It's going to be, what's the interquartile range? And if you put a wrong number in your list, I can't help you there. It's wrong. I can't give you 1 out of 2 points, because I don't know what numbers you put in there. I don't know if you can find it correctly. So please make sure you are careful tomorrow with the numbers you're putting into your list, because it's very few questions tomorrow that receive partial credit. It's really right or wrong tomorrow.
What is it
Out of 26.
How many multiple choice?
Like it matters.
It does to me. You don't have to look at that. I thought you just knew off the top of your head.
No, I don't.
Okay, well then don't look
And the only reason I knew it was out of 26 is I did the answer key like an hour ago. 5. Whoa, 7 multiple choice.
Whoa!
Out of 12.
That's right.
All right, all good? Anything else? You sure?
That's not sophomore year.
You know what it is. All right, so let's go into today's topic. Calculators. We all set with calculators? Let's get them out. You know you're going to use them. Huge unit with those, because I got to show you a new place to go today. And eventually, along the way today, you're going to actually find how the SAT, ACT companies figure out what percentile you fall in, because that's what we're going to do today. When scores are what we call normally distributed. Okay, normally distributed. None of the ones we went over yesterday were normally distributed. Today they will be. And when they are normally distributed, they fall into this curve. that you guys have on your packet right now. They fall into this curve, which is called a normal curve. Normal distribution follows a normal curve. What do you notice about the curve at all? Increases, and basically it's the same on both sides, isn't it? I draw a line right down the middle here at 0. Guess what percent's to the left?
19. Oh, I was looking at the wrong.
50 to the right. So right here at 0, this right here at 0 will be your mean. Whatever the mean is, that's at 0. Okay? So whatever the mean in the problem is, that's going to be right at 0. Now, everyone sees 0.5, 1, and then negative 0.5, negative 1, and so on. Those are standard deviations. Standard deviations. So let's go to a positive 1 right now. That is 1 standard deviation above the mean. So if you remember from yesterday's class, how can I find the score that's 1 standard deviation above the mean? What did we do yesterday? Well, how did we find the score that was 1 above the mean?
We would add this.
Alrighty, we took the mean and added what? The standard deviation. That's how you find that score. You take your mean and you add your standard deviation to it. How do you think I find the one below the mean now? This score. I subtract it from the mean. Mean minus standard deviation. That's how I find these scores. Now, I need you to do one thing for me. Take your calculator. Can you please add up the percent of scores that are within 1 standard deviation for me? What percent of scores are always within 1? Don't yell anything out. Just find them on your calculator. So add up all the scores that are or add up all the percents that are within 1 standard deviation. What is it? What do we have? What are we adding up here? The percents that are within 1 standard deviation. So negative 1 to 1. That means within 1. 68.2%. Yes, 68.2%. Please, that number is going to come up a couple times today. 68.2% must be within 1. All right, my next question. How do you think I get out to positive 2? How do you think I get out to 2 standard deviations above the mean? What do you think I have to keep doing? Oh, is that how you do it? Yes. So to my mean, I have to add the standard deviation and add it again, right? That's how I get to 2 above. How do I get to 2 below? I subtract it twice. So I take the mean minus minus the standard deviation minus the standard deviation. The last thing I'm going to ask you to do, what percent of scores are within 2 now? Because I got to know that number too. So take your calculator. How many are within 2 standard deviations?
I know.
90.
Wait. Sorry.
0.4%. Yep.
How are we getting these numbers?
Maddie, we're just adding up the percents from negative 2 to 2.
Within.
Remember, within means to the left and to the right. Positive and negative. All right, within. Not just 2 above the mean. All right, within 2. All right, so make sure we recognize these if they come up in any of the problems we do today. All right, ready to actually put this curve to use. All right, let's do it. And then along the way, we'll do a little SAT, show you that magic. All right, let's start it off. So we got a set of scores or measures that follow a bell curve. Can you just circle that term right there, bell curve? That tells me they are normally distributed. follows the bell curve. Almost looks like a bell here, I guess. Mean of 80, standard deviation of 5. What percent of scores fall between 75 and 80? Here's how we're going to use the curve to find the percent. Where's the mean go again? Right at the middle, 0. So I put 80 at 0. And now I use the standard deviation to find out the scores above and below. So standard deviation was 5. What's going to be the score at 1 above? How do we find it again? How do I find the score at 1 above?
85.
I take the mean and add the standard deviation. So at 1 it'll be 85. Now I know it's not part of the problem. I'm just showing you how to get there. How do I do 1 below? Subtract it. So what should be at -1? 75. And there's no need for me to go on further because what did the problem ask? 75 to 80. So now I look at the percents from 75 to 80. And that'll be the percent of people who scored between there. Now I just add my percents up on my table. So I had, 15 plus 19.1. There's 34.1% of the scores fall between 75 and 80. Are we okay?
75, oh, and 80.
Right?
Yeah.
75 and 8, not 75 and 85, 75 and 80. All good. Going. All right, let's try one more with the curve here. A set of scores with I need to know this, that they're normally distributed. Because if they're not, I'm not using the curve. All right? I can only use the curve if I know they're normally distributed. Mean of 50, where's it going?
0.
At 0. Standard deviation of 7 now. What scores fall between 36 and 64? All right, can you help me find some? Because I got to find where 36 and 64 are on this darn thing. How do you find 1 above? Yep, so I'm at 57. Still not there, though. Keep adding the standard deviation. So at 2, not a half, but at 2, it'll be 64.
Yeah.
All right. Remember, we don't really deal with the halves at all. Okay, going below now. What's 1 below? 43 minus, right? 50 minus 7, 43. I need 36, though.
And then you subtract again.
Okay, let's keep subtracting 7. What's that -2 below? All right, I think I have it, right? So what percent of scores are between 36 and 64? I don't really need to add. You can add them up if you want. I think we just went over this, right? This is within 2 standard deviations, -2 to 2. So how many, what's the percent going to be? 95.4%. You can add it up and you'll still get the same thing. Anything about using the curve? Go ahead, Molly.
So like the last question, the 75 to 80, would that be like half a standard deviation?
No.
Because it's -1 to 0, not -1 to 1. I know the numbers.
Don't worry about that. We're not going to call it that.
Okay.
All right.
Yeah.
All right. So are we all comfortable using the curve? Because now I got bad news, but I got a good solution to it. Here's the bad news.
No curve.
Ava,
No curve.
curve's never going to be given to you. You're never going to have that. And here's your reference sheet. You get? Anybody see a curve on there? No. Am I going to expect you to memorize the percents? Absolutely not. So good news to this solution. Calculator's got a curve built into it. Don't expect I'm going to press a magic button and this thing's going to pop up. That's not what I'm talking about. All right, but your calculator has those percents built in here. Okay? So it's all calculator now. It's probably even better news. It's all calculator. All right? So here we go. So let's go to number 3. No more curve. All right, no more curve. We got a test to 120 students. The scores are approximated a normal distribution. So I'm thinking to myself curve, but now calculator. Mean of 72, standard deviation of 7. What percent of scores were 65 or higher? All right, here we go. Ready to go to the calc. This is a new space other than 1var stats. All right, we need to go somewhere else. So does everyone see the vars button? Please don't punch it, but everyone see the vars button. Oh, everyone see the abbreviated word right above it.
Vars.
Distribution.
DISTR, distribution. There we go. So that's where we want to go for this one. Second vars. And we only want one selection from here.
One.
No.
Two.
Two. Normal CDF. And at the end, I'll explain what CDF over PDF. Not that it's gonna matter, but normal CDF. That's where we want here when we're doing the normal curve.
Whoa.
All right, so we got to fill in some values. This is where we got to use a little knowledge here. All right. What's my lower bound here? My upper bound. This right here, I know we haven't seen it before, but that's the mean. I still don't know why they don't use X bar, but that's the mean, and we have seen this. That's standard part of the standard deviation, correct. All right, so let's talk about the lower and the upper bound and what I should put in for this particular problem. 65 or higher. I need to know 65 or higher. So what's my lowest number? There you go, 65. Now it gets a little tricky because I don't know how many points are on this test, and I'm not going to assume 100. So what we need to put into the calculator is the highest number the calculator will recognize. The highest calculator the number will recognize, which is the following. Ready? One.
Calculator, the number would recognize?
What?
You said the calculator, the number would recognize.
The highest number the calculator will recognize. All right, we get it. And here it is. 1 above your comma button. You got those 2 E's? This is scientific notation we're plugging in now. Second comma, 99. So really, here's the number you're plugging in right now. 1 times 10 to the 99. 1 with 99 zeros. That's the highest number the calculator can handle. Okay? So there's my upper bound. Alexa, go.
So that's why it's a negative one and the lower one when I first.
Well, we'll get there, yeah. We'll get there. You already know the answer coming up, but we'll get there. What's this here? That's my mean.
No, I mean, one, the calculator.
1, second comma, you got the E's there, 99. What was my mean on this one?
72.
Okay, 72. Standard deviation of 7. Paste, and it'll give you this. Everyone see what's on your calculator screen? This is the work you show to get full credit or to get partial credit if you typed in something wrong. All right, so that's what I'm going to be looking for. Equals normal CDF 65, comma 1E 99, 72, comma 7. That's what I need. I need you to write that so I know what you typed into your calculator. And this is the work to get full credit. All right. So after we do that, we can hit enter. It'll give us a decimal. Now, what's this number represent? That's your percent, but as a decimal. That's not your percent. That's your percent as a decimal. So you can do one of two things. Move the decimal over 2 spots on your own, or just multiply it by 100 in your calculator, either or, but know that this is not the percent. That's your percent as a decimal. So how many people's percent of scores scored 65 or above? 84%. All right, next one. This is how the SAT calculates what percentile you fell in. All right. They find the mean of the exam you took, and they find the standard deviation. We got Big Sue here. She got 740 on the math part. What percent scored below her? This is what they do. They take your score and say, all right, your score, how many scored below you, and that's your percentile. That's how they calculate it. Normal CDF. This is how they do it. All right, so let's go. They were normally distributed. Good. So I go to my calculator now. Little change up from the last one. Second VARs. Normal CDF. Ooh, ready? Go back to the problem. I want 740 or below her. So what's going to be my upper this time? 740. Now my lower, I know it works with 0 and you can't get a negative score on the SAT. I hope not anyway. But I'm still going to have everyone still put in the smallest number the calculator will recognize. All right. Now instead of 1E99, negative 1E99. So negative 1 followed by 99 zeros. What was my mean on this SAT part? 540, right? With the standard deviation of 80. Boom. That's what I show for my work right here. And some of you'll see if you get ahead of me here that Sue is a stud. And what are we going here? To the nearest percent?
99.
I don't know why I did that.
Oh, damn.
Yep. 99 percentile right there. So 99% of the kids scored below her.
You killed
Wait,
it.
ever be 100?
If you scored the top score, it would be in the 100th percentile. Yeah. You scored the top score. Ava, go ahead.
For multiple choice.
I don't need to see any work. Yep, I don't need to see any work because it's right or wrong regardless what you write down. All right, last thing. I do want to take this to another level now. All right. Instead of just finding the percent, let's go a different step now and actually find how many people or how many things fall into that range. Okay? You guys know how to find the percent. Now I want to actually know, hey, how many fall into that range? So we got some soda cans. Mean of 12, deviation of 0.6. We got 250 total. How many are expected less than 11.1? Expected. How many soda cans have less than 11.1 ounces in them? They're normally distributed. Yes, they are. All right, so perfect. Ready? Normal CDF. All right, you guys talk to me here. I want less than 11.1. What's going to be my lower bound? What's going to be my less than 11.1? So what's going to be my lower bound?
What did I say?
Yep, negative E 99, the smallest number. Upper bound? Good, 11.1. What was my mean? 12. And a standard deviation, 0.6. All right, good. Paste that sucker in there. Write it down on my key here. And we find out there's my percent as a decimal, right? So times 100 if you want. So we're saying about 6.7? About 6.7% of the cans. That's not my answer here, though. That's not my answer, right? 6.7%, great. But I want to know how many cans now. So this is where I turn it over to you guys. How can I use my 6.7% of the 250 to find the number of cans?
Do we multiply?
Because this is what I'm looking for, right? 6.7% of the 250 cans. Elliot?
You would multiply 250 times 0.067.
250 times the decimal version. The decimal version, everyone still got their screen up? Don't I still have it there? That's all I need. I'm going to go back to that decimal version and multiply it by how many total I have, 250. And that's how many cans will be less than 11.1. 16.7, so what do we have multiple choice wise? About 17. So that's where I expect, the furthest I expect you to go here. Not just find the percent, but find out how many. Okay, I'm going to do one more with you. I'm not going to do that last one because I need you guys time to practice here. All right, your calculator is going to be worthless here, or normal CDF will be worthless. Normally distributed, the mean's 56, standard deviation of 5. Give me an interval of scores where 95.4% will fall. Oh, wait, what? Oh. That's a number for us. That's all the scores that fall what? Within 2 standard deviations, right? The other one was 68.2 for within 1. I'll do this to you tomorrow, I think, on the quiz. Within 2 standard deviations. So my question, how can you use the 56 and the 5 to get me that range of numbers? I need to fall within 2. So think about it. I'm asking, what would it be at -2 and what would it be at +2? That's what I'm asking, within 2. So let me start with me here. 56, what do I need to do with it to go one way or the other? Okay, add what? 5? Will that get me to 2 above? No, that gets me to 1 above. Another 5 again. So at the top end, it'll be 66. And then how about at 2 below? 56. What do I have to do now? Taking it slow. -5, -5. It'll be at. Okay, so there's your interval. 46 to 66. Will be 95.4%. I'm not going to ask another percent either. It's either going to be 95.4 or 68.2. I'm not going to pull that on you. All right, that's something totally different in the calculator. Looming.
Oh wait, so are those the 2 numbers we have to remember on the curve?
Correct. No, not on the curve. Just 68.2% fall within 1. 95.4 fall within 2. And when I say fall within, I mean -2 to 2, -1 to 1. That's what within 1 means, in between. Yes, no, Lumi? Say what's on your mind, because I know you're
I'm just a bit confused on where you get the numbers from.
Okay, I got the numbers from the curve at the beginning. Because if you go from -2 to 2 and add everything up in between within, it adds up to 95.4.
Oh, okay.
If you go from -1 to 1 within 1, that adds up to 68.2. Okay, that's why I just keep those 2 numbers fresh. Anybody else? Okay, number 7 is kind of like a review. It has nothing to do with normal CDF, and it's going to take more than time than I need, and I want you guys to practice. Have your Chromebooks out. Let's go checking the answers as you go along.